Yes. Do we have to end at 0?
Yes.
Yes. So what are we looking at here? We're looking, I'm coming back now and I'm putting positive and negative areas. So I like these cheat sheets because for me, it's easier to have the picture than to remember all the integration rules. Okay? This is positive, and this is these have 0 slopes, right? These lines are 0 slopes. This is a positive value, this is a negative value. So this is positive. What's the area of this? Let's go to Kyle. What's the area of that? 10 times 15, it's what? 150. And because it's positive, we're going to go up. And why is it a straight line? Because the integration of this line, integration of a horizontal line, gives you a sloped line, right? Right? The equation of this line is y is equal to 10. So if I integrate 10x, and I go 10x from 0 to 15, and I get 10 times 150, and I get 150. I'm basically taking the area of this, and it's a positive area of going up. Plus.
And then, is that, when I was looking at it, is the moment 10 kilometers times 15 feet, is that?
Yeah, but it would be better to go from this because, good question. So Wes is thinking, well, can't I just go back here and say 10 times 15? That's the moment at this point, 150. In this case, it works out.
But it's not.
But it's not going to work out because this is showing you a cumulative situation that's happening over the length of the beam. And as we get to more complicated problems, we're not going to be able to look at that.
We get it from the...
So you look at the shear diagram. I'll point out a little bit. So once you produce the shear diagram, you go straight to the moment. So let me, yes, it goes up to 150. Let me interrupt that for a minute. So Chris, this is you. When was there a vertical change in the shear diagram? What was going on up here to cause a vertical change in the shear diagram? A concentrated load, right? This is called, isn't this a point load or a concentrated load? If there's a concentrated load, you have a vertical change in the shear diagram. So what do you think would cause a vertical change in the moment diagram? Not a concentrated load, a concentrated moment. Does this problem have a concentrated moment in it? Does this problem have a concentrated moment in it? Does this problem have a concentrated moment in it? Yes. So I always look at the top and I put a little dot here to remind myself, there, I have to do a vertical change. Is there a concentrated moment here? Yeah, where? On the beginning. Say it again? That's a concentrated load. We were just looking for concentrated moments. We've already taken care of all the loads with this diagram. Now we're looking at where would there be a vertical change in the moment diagram.
Yeah, I think I was like, where's the John Muir? No, wait. Okay, that's it. So, yeah. my dad was trying to do it.
Okay, you guys, we noticed that whenever there was a vertical change, when there was a concentrated force, there was a vertical change in your shear diagram. What I'm pointing out to you now is when there is a concentrated moment, there's going to be a vertical change. But we haven't done it yet. I'm just putting little notes for myself to remember. So can we go back over here now? This problem has no concentrated moments. Does everybody agree? So I don't want to look at this ever again. I am only going to look at this. Once I produce the shear diagram and I'm working on the moment diagram, I do not need to go up here. I am only going to look at the shear diagram. So here, there was a 150, it went, because it's positive, it goes up. Where am I? Jill, so what's going on here? Do you see anything here? No, so what do you think it's gonna be? Straight line. And then it's gonna go down, and why is it going down? Because there's 150 here, and then all this gets colored in. So what do you want to design this beam for, in terms of moment? 150 foot kips. So if it fails in the middle, do you think it's failing in shear or moment? Moment. You're just looking at the pictures. If it fails in that second section, it was experiencing no shear, but it was experiencing 150 foot kips of moment. Wes?
Just looking at our project this morning and talking about the safety 5 times.
Say it again, what?
The safety factor 5.
Yeah,
Would someone get this answer and just say, all right, let's do it times
5. The factor of
Double
safety,
it.
the factor of safety you choose is based on so many things. Mostly, the larger the unknowns, you know, like who's gonna stand on it, or the material that you get, is it gonna be good material, or you're not sure, then the number goes up.
Okay.
So, for you guys, I don't know, maybe 2 or 3?
Yeah.
Okay, so let's do this one. Are there any concentrated moments in this problem? No, so do I need to look at the loading up here anymore to do the moment diagram? No, what do I need to look at? Only the shear. So Peter, we're up to you. Do we start at 0?
Always.